Aloha, Richard Halverson here. This is ICS211, and today I'm going to get you started in sorting. So let's share my screen. Okay, so chapter 18 is where I've put this beginning chapter on sorting. And so I'm going to go into presentation mode and make sure you need to make sure you click through all the participation activities to make sure you understand what's going on. Let me switch over here. And the first little demonstration here has you see how fast you can sort values. And so what you're going to do is there's going to be some numbers that appear here, and then you're going to click two numbers to exchange until you're sorted. Now there's of course there's lots of different sorting algorithms. We're going to learn a few of them. Pop this down here. We're going to learn selection sort today, and then next video we're going to cover insertion sort, and then quick sort, and then merge sort, and we even get heap sort down here in a couple chapters away. But anyway, so we are right here right now, and so let's see how this works. I close this, click on this, and you go. Let's see. I want first one. I'm going to do a selection sort kind of thing where first I find the lowest one, then I find the second lowest one, put it in its proper position. Third lowest one is it's there already. Fourth is this one. Fifth one is this one. Oh, and we're done. Okay, so that's one way of sorting where I each time I went and found this next smallest number to put in its position. There's a bubble sort, there's an insertion sort. We'll cover several of these. So let's specifically go over selection sort. Selection sort is a sorting algorithm that treats the input as two parts. There's a sorted part on the left and an unsorted part on the right. And we have a variable I here that keeps track. This goes from the first element all the way up to the second to the last element. And then inside here, we loop from where I is, from I plus 1 up to the last element. And so wherever I is, all of the elements to the left of I are sorted, and all of the elements to the right of I have yet to be sorted. So if we start this, we see first I is equal to 0 and J is equal to J plus 1. So what's going to happen is J is going to go all the way down the line here, find the smallest one, and exchange it with I. So J is going to go, first it sets I as the smallest, and then it's going to go, this is not true, so it tests this one, this is smaller, and then so then it exchanges. No, this is the smallest one so far. Gets all the way to the end. Since it knows that this is now the smallest one, it can exchange 3 with 7. So that's what happens down here. Exchanges 3 with 7. And then now now it's done. I is here, and we increment I. And we reset J. And so now everything to the left of I is sorted. Everything to the right of I is yet to be sorted. Now we're going to go down the line and find the smallest one here. It's going to be 7. And then we exchange that with the 9. And we continue on like that. So we go down the line and we find that this one is the smallest one. So then we exchange it with and this is just a temporary variable here. All right, so why don't you finish going through this to make sure you get the participation points up here. Just quickly watch it finish. And that's how selection sort works. And this is the algorithm. So I starts out at 0, goes up to here. I starts at this position, goes up to here. J starts at whatever I plus 1 is each time it goes through the loop. goes through the rest of the array, finds the smallest one, and exchanges it with I down here. Here's the full algorithm. It shows here we are initialize an array, an integer array. We output the unsorted integer array. We call selection sort on this array of numbers. And what we get back is the numbers sorted. And then we print them out here. And this is the selection sort algorithm up here. All right, so let's do one of these. Let's see. When using selection sort to start a list of 12 elements, what is the minimum number of assignments to the smallest index? The minimum number of assignments to the smallest index would be 11, because smallest index is assigned right here. And so it's assigned from 0 to the number of elements minus 1. So the number of elements is 12, so it must be 11. I think that's right. Let's see if that's great. I'm going to say 11. I was right. Okay, you can do the rest of them. Just test your understanding of selection sort. All right, now we're going to do a lab. Okay, in this lab, we're going to not do selection sort. The examples of selection sort that we've been looking at have been where we start out by assigning this minimum number, this minimum integer, where we're going to be doing a descending selection sort. So each time we go through the list to find not the smallest one, but to find the largest one. So we're going to build up this list, the biggest one first, and then the next biggest one, and then the next biggest one. So the array will be in descending order when we're done. So if the input looks like this, and here we're writing this program to read in an input, and to read this, we have to read this input, and it's going to be a maximum of 10 integers, and then we're going to call this selection sort descend trace method to output, or to sort it. And the way it's going to work is each time we sort, or each time we go through the pass, the inner loop, each time we're done with the inner loop, we're going to display out what the current status of the array is, what the current array is. So what we're talking about here is it's back here. Once we go through this inner loop, once we're done with this inner loop, and we're done swapping, then we print out the array. So we print out the array once for every outer loop. Okay, so let's see what we have to do. So here we have to actually write. We have to write the whole selection sort program, and here we have to write where we read in. Okay, this thing has to take this array of integers, sort them with selection sort, and then we have to display it out, don't we? Doesn't it say we have to display it out at the end of each? A method should use nested loops and output the array after each iteration of the outer loop, thus outputting the array this many times, where n is the size. Okay, so let's start out by reading in the array. And let's see, I've got some, I don't want to set you astray here. So we're going to use the scanner. And the first thing I'm going to do is I'm going to input the first integer. So I'm going to say SCNR of, we're going to use this input here. Input equals SCNR dot next int. Okay, so that's going to grab the first integer. And then while the input is not equal to -1, while the input's not equal to -1, then take the input stored into the array. I is 0. Both I is 0. We're going to use I for that. Numbers I equals input. And then we can increment I. And then we can, oh, we're supposed to be keeping track of the number of elements too. Well, I'm just going to set that at the end. Okay, and then we're going to read the next one. Input equals SCNR, next int. And this is going to keep on looping until the input I is equal to -1. At that time, I will equal, I will actually equal the number of elements in the array because it starts out at 0, and each time we add an input, we increment it. So this is actually I is actually not only the index for the array when you're storing a value into it, but it also, once it's incremented, that's the number of elements that are in the array. So at the end here, I can just say num elements equals I. And I wasn't sure why I was supposed to store the number of elements, but do I print that out somewhere? I don't know. Now where do I call? I need to call it. So that's probably where I do it. Okay, so here I call this thing. I call selection sort. All right. So we have to call this program here, this method, it's got no output. We're going to call it on first one we send in there is numbers. It's called numbers, same. And then we're going to say the number of elements. I guess that's what this num elements is. I'm just going to use I suppose. All right, so then this is going to sort it. And once we get here, we're gonna do the selection sort, and we're gonna and then at the end of each outer loop, we're gonna print it out. Okay, so you know what I'm gonna do? I'm gonna I want to save this, so I'm gonna just save it by doing this, running it. And it's not going to do anything, but at least I've saved it. And now I'm going to go up one, back up to where selection sort is. And I'm going to copy this thing. I'm going to copy this. Copy. And I'm going to go down to the next one. Wait a minute. I need more than this. I need one of these too, don't I? I'm going to copy. I'll just do this. Okay, first I'm copying this. And I'll put that, it's still there. Yeah, it's still there. I'm going to put it here. What is this? Undo. Go back here. Go back to, go up to selection sort, do a right click. What's going on? This thing's all messed up. Right click, open link in new window. Man, JavaScript gets all messed up. I'm going to put this here, and I'll put this here. And so this is where I'm working. And this is the selection sort from the other side. Okay, I'm going to copy this. Copy. Is it paste? Paste. Why is it looking like that? I don't want any of this. I'm going to open a new window, and I'm going to go over here. I'm going to copy this, copy, paste. Okay, I don't know what all this crap is down here. For loop, and I don't know what all this is, so let me get rid of that. And so this is the actual this is the outer for loop, this is the inner for loop, and this is the exchange. This is the exchange because it found the smallest one, and then it exchanges it with where I is pointing to. But we also want to print out something, don't we? Where's here's something that prints it out. This prints it out. So I'm going to copy this, and I'm going to put that right here. Okay, so this, I don't need this, I don't think. But I would like to print out this, and I'm going to use, I don't want to use J because this is, I don't want to use I because this is inside of the for loop. This is J, this uses J here, and we're going to use J again here. I'm going to use J to print out everything. Numbers length, J plus J, and we're going to print out numbers J like that. Okay, let's all right, this should all be indented, including this. Put this one in there too. And then this is inside the for loop. This should be indented. And this is inside the if. That should be indented. This should be inside the for. Okay. And the other thing, okay, so I'm just going to copy this in here now. Copy. And now I can go right to here, and I'm going to put that in here. Okay, this is how we start. And I'm going to copy what I had over there right in there, paste. Okay, so this is our selection sort. So this is the outer loop and finds the smallest. We're supposed to find the largest, but I'm going to get it working with the smallest first. Find the smallest. This is the loop, and we get a number of elements. It goes like this, goes to there's nothing wrong with using numbers length. We can use number of elements or numbers length. We probably should use number of elements since that's what they want us to use. I'm going to put that here, and I'm going to put that here. And I'm going to put it here. Okay, I'm going to run this to see that this sorts in ascending order. Okay, so I'm going to use these numbers here. And I'm going to put it here. And I'm going to run it. And we should see that it prints out each. Cannot find this symbol. It doesn't look like I got to initialize these things. Okay, this one. This up here. Ooh, I got to do all this stuff. Integer index smallest. I might as well just it doesn't matter. Index smallest, int I, int j, int temp. Okay, now let's see what happens. Run this. Out of bounds. Something is not stopping this properly. It's in the input. What is out of bounds? Index 10 out of bounds for length 10. Java 30, Java 53. Ooh, this is what it displayed. It is. Okay. Java 30 is here. Ah, look at this. That should be J. I use J here. Okay, J. Okay, let's see what this does. Okay, it prints out each time. Wow, it's okay. I'm gonna change this to okay. Well, anyway, it sorts it in ascending order. We need to change this so it sorts in descending order. Okay, so I'm gonna call this index largest just so it's consistent. Index largest. I don't have to change the name of it, but I'm going to just so it's clear. And then this is going to be this. This is going to be this. And it's index largest. It's an index. We're using it as an index. Index largest. These are all J's. I. Okay. With index largest. Okay. And this is the test. If the number that we're looking at, J, is less than index largest, then index large. Okay, so we want to set numbers. We want to set J equal to the index largest only if the numbers of J is greater than the numbers of index largest, because this is supposed to be the index of the largest. And this is testing to see if J is smaller. We want to test if it's larger. Very simple. So let's just change this to from a less than to a greater than. And let's see what this does. Okay, what is it supposed to output? 40, 10, 30, 20, 20, 20, 10. Yes. Okay, well, that looks pretty good. All right. So I've taken you through selection sort. Hope this helps. Thanks for watching.